Sulfur is one of the elements in the periodic table which exhibits allotropy. In our lesson on what is allotropy, we described allotropy as a phenomenon where an element occurs in different forms but in the same physical state. In this lesson, you will learn about the allotropic forms of sulfur and the relationship between them. Like carbon, sulfur has both crystalline and amorphous allotropic forms. However, we will only focus on the main crystalline allotropic forms of sulfur for now. They are rhombic and monoclinic sulfur. Rhombic sulfur is sometimes denoted as alpha sulfur, while monoclinic sulfur is sometimes denoted as beta sulfur. The most common allotropic forms of sulfur is rhombic sulfur, which has an octahedral shape. It is the form in which sulfur is found naturally in its free state. A molecule of rhombic sulfur looks like what you can see in the image shown. Rhombic sulfur consists of 8 sulfur atoms, which are held together by strong covalent bonds. The 8 sulfur atoms are held together in such a way that they form a ring-like structure that has a crown shape. Maybe that makes rhombic sulfur the king of allotropes of sulfur. Or what do you think? As said earlier, rhombic sulfur is the natural elemental form of sulfur because of its stability at temperatures below 96 degrees Celsius. This means that rhombic sulfur can be obtained at room temperature, which is about 25 degrees Celsius. Monoclinic sulfur, on the other hand, cannot be obtained at this temperature. It can only be obtained at temperatures above 96 degrees Celsius as a crystalline amber-colored needle-shaped substance. Like rhombic sulfur, it is also consisting of 8 sulfur atoms held together by strong covalent bonds, but with a different arrangement. One interesting relationship between rhombic and monoclinic sulfur is that they can be transformed into each other by manipulating temperatures above or below 96 degrees Celsius, which is referred to as the transition temperature. For instance, if octahedral rhombic sulfur is heated and its temperature increases above 96 degrees Celsius, it transforms into monoclinic sulfur, which has a needle-like crystalline structure. On the other hand, if monoclinic sulfur is allowed to cool until its temperature falls below 96 degrees Celsius, it transforms back to rhombic sulfur. To conclude this lesson, let's do a recap of what we have learned so far. The main crystalline allotropic forms of sulfur include the rhombic and monoclinic sulfur. The rhombic sulfur has an octahedral shape and occurs at temperatures below 96 degrees Celsius. Monoclinic sulfur has a needle-shaped structure and is stable at temperatures above 96 degrees Celsius. Rhombic and monoclinic sulfur can be transformed to each other at their transition temperature, which is 96 degrees Celsius. And this is where this lesson ends. I would love to see you in the next one.